Hi, I'm Mrs McTaggart and I'm going to take you through the Paper 2 Practice Paper C available from the National 5 website. So you're allowed a calculator for this one. Question 1 is your standard percentage. We have bacteria in a test tube increasing by 4.6%. And we're doing it from 12 o'clock to 5 o'clock. So that's it increasing for 5 hours, okay? So if something's increasing by 4.6%, in your head you do 100 plus 4.6 is 104.6%. Now this is a quick way of doing it. So as a decimal, you basically divide that by 100 and your multiplier is 1.046. And keeping times and like that is a lot quicker than finding the percentage, adding it on, find the percentage, adding it on. So that's what we're multiplying by. Because it's for 5 hours, we're multiplying by that 5 times. So we do the power of 5 and we times that by the starting value. And this will give you the answer if I just quickly type it in. 1, 2, 3, 4. This gives you 6267.79, blah, blah, blah. Now then ask for your answer to 3 sig figs. So please always put down your unrounded answer first, just in case you can't do significant figures very well. So significant figures means I'm going to keep the 626 and the 07 both turned to zeros. So that will be the number of bacteria you will have after 5 hours. Okay? Nice. Standard bread and butter question for your question 1. Some more. Oops. Okay, so this is a missing angle one. I've already marked on what we're after. We're after angle JLK, so I've marked that in red. It tells you that we have a tangent. So whenever you have a tangent, you have some right angles. So wherever your radius meets the tangent is 90 degrees. So I'm just going to put these in here. So there's a 90 there. And there's also a 90 on that side as well. So these are both 90 degrees. Radius always meets a tangent at 90. Now I also have basically 2 semicircles there. Whenever you have a triangle inside a semicircle, the angles on the outside are also 90. So I'm just marking in some more right angles. Okay. Right, let's start filling in some angles. So if I use this triangle on the right hand side, this angle in here is 90 take away 47. So 90 take away 47 is 43. So this one is 43. Using the one on the other side, I've got 90 plus 31, which is 121. And then if I do 180 take away 121, that leaves me with 59. So this one in here is 59. Now my complete angle to conclude the question is angle KLJ. I've actually written that back to front, but it doesn't really matter. Equals 59 plus 43, which is, oh my goodness, 102 degrees. Couple of tips for this question. It's so much easier to just write your numbers in. If I hadn't written the 59 and the 43 on there and just had all this working, the person marking it would have no idea what you're doing. So I've done a combination of working and drawing on. And at the end, I've concluded what my final answer is. If you don't do that, you will lose marks. Question 3 is a change of subject, so we want it to be X. So some pupils prefer to put the thing that they want over onto this side. So I'm just going to do that just now. Remember, our aim is to get the X on its own. So we need to deal with the A, the cubed, and the plus C. The first thing you deal with is the thing that's not attached. So that is the plus C. Plus C is going to go to the other side and become minus C. So you've got Y minus C on the right hand side. Then we deal with the multiplying by A. The opposite of multiplying by A is dividing by A. So we divide that whole side by A. And then the last thing is to do the opposite of cubing. The opposite of cubing is cube rooting. So that is like a big square root sign with a 3 in front. Okay, and one thing to point out here is please make sure the square root looks like it's going over the full thing. For example, if we see this as a marker, it's really, really annoying because it looks like the cube root is just over your top line and it should be over the full fraction, all right? So please be very careful. If in any doubt, make it like extra large. Okay, question 4 is a volume question. So we want the volume of a mug. Now this is the only formula one you need to know off by heart It's pi r squared h. It's basically the exact same as a colon, but without the third in front. So that is a formula for it. So part A wants the volume. So we're simply substituting in. So we've got pi, our radius is half of 10, so 5 squared times 14. And if you go work that out, we have 1099.56. That is the volume of the mug. And that is going to be in centimetres cubed. Or that could also be millilitres, because a cubic centimetre is the exact same as a millilitre. So that's part A. Part B, it says 600 millilitres of coffee are poured in. Calculate the depth of coffee in the mug. So the mug still has the same radius. It's the height that's kind of changing, the height of the coffee that's changing. So remember, 600 mils is just the same as 600 cubic centimetres. So we know what the volume is. We know what the radius is. We need to get the height. So we start with that formula again. V equals pi r squared h. Your volume is 600. Our radius is still 5 squared. We just don't know the height. Now your aim is now change the subject. Our aim is to get h on its own, so we have to deal with everything else that's on the other side. Now h is being multiplied by pi times 5 squared, so we're going to divide by that, and you can just move that down in one swift go and make that divide by pi times 5 squared, and that'll give you the height. And if I type that in, oh goodness, it gives you, I've got running out of room here, you get 7.639, so 639 would go to 7.64, so that is the height of the coffee, and they've not mentioned any kind of rounding, so it's up to you if you want to do 1 or 2 decimal places. So quite a classic volume question, part A, get the volume, part B, work backwards. Okay, question 5 is about a Ferris wheel. It tells us that the chairs are all equally spaced out. There's 16 of them. It tells us that the radius of the wheel is 9, and the wheel is turning from T to P. So that is turning 1, 2, 3, 4, 5, 6, 7 segments. So it's turning for 7 out of 16 segments. Now, this is basically asking you to find the distance the chair's travelling. So it's asking you for this arc length of this shape here. So I'm just going to draw a little sketch of what's going on. So it's looking for this arc. We know the radius is 9, so our radius is 9. We need to get that angle in the centre. Now to get the angle, you're going to do 360 divided by 16, because there's 16 chairs. And then we're travelling through 7 of them, and then you'll times that by 7. And we get an angle of 157.5. So this is what we're working with. So to find arc length, remember the formula for arc is arc equals your angle over 360 times pi d for arc, because it's like circumference. So we've got an angle of 157.5 all over 360 times pi times, well, if your radius is 9, your diameter is 18. And if you type that in all in one go, you will get an answer of 24.74 metres. Okay, so it's just an arc one put not so nicely. Okay, our next question, find the roots of the equation to 1 decimal place. So whenever you have a trinomial equal to 0 and it mentions 1 decimal place, that is your clue that we are using this, the quadratic formula. Now that's on your formula sheet, so please make sure you copy it down correctly. I always do A, B, C at the side. So A is the first number, which is a 2, B is the middle number, which is a 4, and C is the end number, which is a -9. It doesn't look much like a -9 just now, but there we go. And I always work out the 4AC as well, just to make my substitution a bit nicer. So 4 times 2 times -9 is -72. Right, so let's substitute in. So x equals, minus b is always the opposite of what you've put there, so it's -4 plus or minus. B squared is 4 squared, so I go straight to 16. Take away -72. And then you can nicely, there's not hundreds of substitution, there's just 2 numbers, and you can see that that double negative is going to turn into a plus. If you didn't have a double negative there, you would be square rooting a negative number, which is impossible. You have messed up. And it's all over 2a. A is 2, so that's 2 times 2, which is 4. That's your first mark. Then you tidy up the discriminant. You tidy up the bit under the square root. So you do 16 plus 72 is 88. All over 4. Now, you never work out the square root of 88. You never turn it into a decimal. You keep it nice and exact. And from there, you split it into 2 sums. So you do one with a plus. And you do one with a minus. Okay. And then you go to your calculator and you type that in. So if you're using a fancy new Casio, you can press your fraction button, the one that gives you this, and you can just write the top line and the bottom line. And it also makes it that you can just go back and edit it as well instead of typing the whole thing in. If you're not using a Casio on that mode, then make sure you press equals at the top line, otherwise your calculator will do mod BODMAS and do that divide by 4 bit first of all. So type that in. So for the plus sum, you get 1.345, which to one decimal place as asked for is 1.3. With the takeaway sum, so I'm literally just going back to what I last typed in and I'm editing it to change that wee sum into a minus, and it just saves me a wee bit of time. And it gives me an answer of negative 3.345. So to one decimal place is negative 3.3. So they are your roots. Okay. Next question is similar shapes. It tells you that they are mathematically similar, so that's your clue that it's similar shapes. And it wants the volume of the big one. So the first thing you do is you get your scale factor. So your scale factor, because I want the big volume, I put big over small. Some of you might call it new over old. So it's 9 over 6, which can simplify down to 3 over 2. We then say that the big volume is your scale factor cubed times the little volume, which is 30. Now, the reason we cube it is because that's the rule. If it's similar area, you square it. If it's similar volume, you cube it. And your teacher should have explained why way back when. But please, if it's volume and you're not sure whether to square it or cube it, just remember in volume, you write cm cubed at the end, or cubic centimetres, with a wee 3. So we put a wee 3 in for the power. Now, I'm doing this as if I don't have a calculator here, so I'm just going to work through the working if we didn't. I know we can go do 1.5 cubed times 30, but what if this was non-calculator? You would then say, oh, wait a minute, that's 27 over 8 times 30, and then maybe do a bit of times by the bottom, divide by the bottom times by the top. And that gives us a nice answer of 101.25 millilitres. So that is the volume of the big one. So as I said, this wee line here kind of really isn't essential. I was just talking through what you would do work-wise if this was non-calculator. You can just go straight from here to here, and feel free to change the 3 over 2 into 1.5 if you want to. But if it's not a nice fraction, if it's not a nice decimal, sorry, keep it as a fraction. Okay, question 8, determine the nature of the roots of the equation. So to do the nature of the roots, you have to have, that's your, minute you see that, that means you're doing b squared minus 4ac. And whatever number you come out with there will tell you whether it is got no roots, 1 root, or 2 roots. So the first thing is it's not in the right kind of layout, so I need to multiply this out. So that means you've got x minus 2 all squared minus 5x. So that gives us x squared minus 2x minus 2x. I'm going to skip a line. Gives us minus 4x plus 4 minus 5x. Put this in the normal layout. You've got minus 4 minus 5 is minus 9. And that's what we need to do. So a is the first number, b is the middle number, and c is the end number. So b squared minus 4ac. B squared is minus 9 squared, so I'm going to go straight to 81. Remember, anything squared is positive. Take away 4 times 1 times 4, which is 81, take away 16, which is 65. So b squared minus 4ac is positive. So you write b squared minus 4ac is greater than 0. And when it's greater than 0, that means you have two real and distinct roots. You must mention real and distinct roots. In terms of a picture, what's going on is you've got two roots like this. So two clear places where it's cutting the x-axis. Okay, question 9 is one of the, I can just tell by looking at it, it was a really, really horrible Pythagoras question from years ago. It's a tunnel tanker, but it's got a bit more algebra in it than normal, so let's have a look. So we've got this shape here, and it wants you to find the length of OB, the radius. Now, you don't normally get asked to find the radius, so I'm just going to call that R. That's what we're working out. Using this little triangle, I know that that bit there is 3 because it's half of 6. And then if this bit here is 2, this little bit is going to be your radius minus 2. So I'm going to call that R minus 2. Now, you normally only ever have one unknown with Pythagoras. This has got an R in 2 different places. But please remember what Mr. Pythagoras said. He said that a squared plus b squared equals c squared, didn't he? He said that the two short sides squared and added make the long side. So that means I've got r minus 2 all squared plus 3 squared equals r squared, where these are your two shorter sides. And then we've got a heck of a lot of algebra to do now. So let's make some more room. To square out your brackets, if you need to, go do that at the side as 2 brackets. I'm going to go straight to the trinomial. So that gives me r squared minus 4r plus 4 plus 9. 3 squared is 9 equals r squared. Now from there, if I take the r squared to the left, you've got r squared minus r squared, it'll cancel out. If I take it to the right, it'll cancel out again. So basically, they cancel out. And you're left with minus 4r plus 13 equals 0. Take the 13 over or take the 4r over, it's up to you. So you're left with that. The negatives will cancel out, so you've got 13 over 4. And as a decimal, that's just half it and half it. Or in fact, we've got a calculator if you want to. That gives you 3.25. So the radius of the thing is 3.25. And that's fine because if you look back at the triangle, this side was your radius take away 2, which could be 1.5. This side was 3. And if that's 3.25, it's okay because it's still longer, isn't it? So there we go. I don't like that question. Okay, next question. We have a parallelogram. That means we've got two identical triangles. So these match, okay? They're just kind of spun around and flipped. It says find the size of angle PQR. So I'm after this angle here. Now in maths, when you're asked for an angle, I always say, right, try cosine rule. Cosine rule formula needs 3 angles, and that's what it is. So it is a cosine rule for a formula. So it's going to be cos Q equals p squared plus r squared minus q squared all over 2pr. Now, you don't necessarily need to change the letters at all. As long as you know the number that becomes the takeaway is the one opposite the angle you're doing. So quite often when I'm teaching my class, I'll go straight to the numbers and they'll go down straight to saying, right, well, cos q is the 2 sides on either side. And they know that the one that's the takeaway is opposite the angle they're finding. So there's my top line all over 2 times 8.4 times 11.2. Okay, so that is that line of working. So then cos q is, work that out, it gives us 0.1979 and it keeps going. You then hit shift cos to get what the actual angle is. And you get an answer of 78.58. Now to see with angles, I say just go to the nearest degree. So that rounds up to 79 degrees. So that's all part A, okay? If I go back to the question, part B says it wants the area of the parallelogram. Now, area of a triangle is half AB sine C. So I'm going to do, for part B, area equals half AB sine C. Now, with area, we're using these two sides and the angle in between, which we now know is 79. So we've got a half of 8.4 times 11.2, and I'm sorry I can't fit this all in. So you do that, so half times 8.4 times 11.2 times sine 79. Technically, I really don't even need to put that half in because we've already said that these triangles are identical. So it gives you 46.175. So let's say that's 1/8. So the total area is 2 of them. So we need to times that number by 2. And it gives us 92.35. I'm using the exact answers, cm squared, because those triangles are identical. Now, say you're sat there and you don't know how to get the angle for part A. You don't want to lose all the marks. I mean, this is 6 marks worth. So if you're not sure, make one up. It's clearly something just below 90. So make up an angle, take the hit in part A. I mean, I could have said, oh, that's 80 degrees or 84 degrees. As long as I then did half AB sin C correctly for the second half with whatever my made up angle is, it would have been okay, as long as I had maybe drawn it on my diagram to show what I was using. Okay, question 11. This is one of your all sine tan cos ones, the one where we use this table. So first thing you have to do is change the subject, so you've got tan x on its own. So you have 2 tan x, move the 7 over, is minus 7, divide by 2, so tan x is minus 7 over 2. Because tan is negative, we don't use all in tan, we're going to use the opposite too, we're going to use sine and cos. Your acute angle, we'll be doing shift tan, or inverse tan, of 7 over 2. Remember, never put that negative in, okay? So the acute angle comes out as being, so the nearest degree gives you 74 degrees. So our answers in the sine box, I'm going to have to come down and use this space. So in the sine box, x is 180 minus 74. And in the cos box, it's 360 minus 74. So that gives us answers of 106 degrees and 286 degrees. Please use your calculator. I had to go to my calculator because I don't want to mess up. So that is your answers to part A. Part B is one of these horrible trig identities, and we hate them. Right, we need to prove that this is equal to sine x. So first thing I'm seeing is there is a common factor here of sine x. So I am going to rewrite this as sine x, bracket, that will take that down to sine squared x plus cos squared x. Now, one of the rules you're told to remember is that sine squared x plus cos squared x equals 1. So that's just sine x times 1, which is just sine x. That's all that one was. So the two rules you're told to remember is that tan x is sine over cos. There was no mention of tan in this one, so we didn't have to use that one. And the other one is just that sine squared plus cos squared equals 1. So that's the one I have used there. 2 marks. Don't lose any sleep over it. Everyone hates them. Okay, question 12 is a bit of a strange question. It's speed, distance, time, and I'm not sure how relevant to National 5 this is anymore, but I'm going to work through it anyway. So part A, a driver travels from A to B. This is our distance, and this is our speed. We have to find time. Now cast your minds way back to when you did speed, distance, time. Do you all remember this wee triangle? To find your time, you do distance over speed. So your time is your distance divided by your speed. So in this case, our time is our distance of x over a speed of 75. And I can't do anything else with that right now. So that is my time. It then says the time taken for the journey from B to A, so that's the return journey, is x over 50 hours. Calculate the average speed for the whole journey. So your whole journey, your distance was x on the way out plus x on the way back. So your distance was 2x. Your total time was x over 75 on the way out and x over 50 on the way back. Now, to do that time, you have to make them common multiples. I'm actually going to turn them both into 150. So I'm going to times this first fraction all by 2 and the second fraction all by 3. So that gives me 2x over 150 plus 3x over 150. So a total time of 5x over 150. That can simplify down. If I take out a common factor of 5 there, divide them both by 5. that gives me x over 30. Now, to get your speed, remember the formula for speed using that triangle? Oh, I've done that the wrong way. So to get speed, you're left with d over t. So speed equals distance. I'm going to write it this way because I know what's coming. I'm going to end up with a fraction over a fraction. So I'm going to write this one left to right. So my distance is 2x. My time is x over 30. So this is really an algebraic fractions question put in with some nasty speed, distance, time. To divide by a fraction, remember you keep the first one, change it, flip it. Keep it, change it, flip it. And it gives you that. Those x's will cancel out and you're left with 2 times 30, which is 60. So your average speed is 60. Was the distance in miles? Yep. So my average speed is 60 miles per hour. I feel like a rock star whenever I do that question. It's horrible. But anyway, that's it. Thanks very much for watching.